Since we've done this before, I'll go through a little bit faster. Common factor is our first one, right? We reviewed this a little already this year. So common factor is our first one. It's always, always, always going to be the first step for all factoring questions. Always look for common factors no matter what. You always want to reduce your numbers as much as possible. Okay, so then here, what do we got? What do we got? Between a 6xy and a 3x, as soon as you look at that, we go, yes, definitely can see a 3 in both of them and an x. So what's common between them? And then what's left over, we have a 2. I took out one of the x's, so I only have one x left. I have the y left, and then here, what do I have left? What do we do for nothing, though? Don't put 0. Plus 1, yeah, so plus 1 to represent that 3x times 1 got me my 3x. Right, so it's all gone, so it's a 1. Okay. Here, it's already grouped for you, the common factor, so we know that this guy and this guy are the same. Right, so I usually write that first or second. It doesn't matter the order. So you can write it first or second. Right, for factors, it doesn't matter. Oh, wait, here, we always want the monomial first. Right, so monomials will be first. So monomial first. Okay, so put the monomials first, please. That says monomial first. My writing got messy right there. First. Monomial first, then the binomial. Right, we always put monomials in front. We always clean them up and put them in front. Okay, not after typically, and not in the middle. Like if we have a bunch of factors, we don't put it in the middle. We go monomial first. The shorter ones first. So here, x plus 3, I don't care if it goes first or second. And then what you do is you write down what's left over. So if I took out the x plus 3, what's left over is the x minus 2. That's it. And it doesn't matter the order, up to you. Okay. This one here, a little different. I don't know if we gave you this in grade 10, quite honestly. I gave you 2 of this one and only 1. But there's still a common factor, right? We can see it's the same as this, but look, I had 2 of this one and 1 here. So when I take out that common factor, so I take it out, say same as what I did here, took it out, write down what's left over. What's left over? If I took away one of those from here, what's left over?
One of those and the x.
Yeah, one of those still. And the minus 8, perfect. Do I need the bracket on that? No, because nothing's happening around it. So then let's fix that up. If you took it out on the first step, that's fine. But if you're like, ooh. So what we don't want is we don't want extra brackets on our answer. Okay, we always want to finish this up, right? So we want to finish in the bracket. Whenever possible, we want to collect up the like terms. Can I do more? X plus 4 minus 8? Can't I finish that a little bit more? Simplify a bit more? Yeah, you can. And so you're going to write down x plus 4 and then x minus 4. Does that make sense here? You want to finish up. You don't want to leave it with the plus 4 minus 8. Why don't you just clean it up? Simplify. Okay, so that's the patterns. We want to keep going until we can have each bracket cleaned up. Yeah.
What if you do the other way?
Expand it, collect like terms? Yeah, you can do that too. Yeah. Yeah. Sometimes, though, on purpose, I give you different letters, and you can't do it the other way. So the question was, can you expand it, collect, and you would get the same answer? Yes, but sometimes I give you funny numbers, and they will not expand and collect. Like if I gave you a W here and a Y there, then you're stuck. You have to do it this way. So try to learn this method because it will come up. Yeah, in grade 12 we use this method too. Yeah. Yep. Because I took one of them here and one of them there. Those 2 are the squared. So x plus 4 and x plus 4, there was 2 of them. That one went out in front. So see what I did here. I took the 3 out and I wrote it once. I took out the 3 from both of them. Right? So here I'm taking x plus 4 out from both of them. So it disappears from both. It doesn't become squared. So it's not 2 3s I took out. I took a single 3 out from both. I took a single x plus 4 out from both. Right? So you're grabbing 1 out from both of them. Okay, here we're going to do 2 by 2. So when you have 4 terms, we're going to group it 2 by 2. So when you see there's 4 terms, we're going to group it 2 by 2, but I'm going to change that. So last year, all we had was 2 by 2. We're going to do 3 by 1s, and I'll show you what that means in a bit. Right, so that's the next, that's the next part. Yay, you're supposed to be like, yay, more factoring. Yes, I wanted more. Okay, so that's why. So it was always 2 by 2 before, so that's why I usually would say the rule is when you see 4, go 2 by 2. No, that's not a rule now. We're going to look 2 by 2 or 3 by 1, and I'll show you that type next on the second half of the 2-3 lesson. All right, so that's why it'll be changing a little bit. So not always 2 by 2, that'll be one check, and then we'll do the next one. Okay, so if it is 2 by 2, what we should be able to find out is that there's a common factor between the two. So if I cover that up, the common factor there would be 5x squared. And then you're left with, I take the 5x squared, I get an x minus 2 left. Okay, then I take a common factor out from the next two, so 4, and you've got x minus 2 left, correct? So common factor out from the first two, common factor out from the next two. Now we're at the same step as we were up here, where look, they're the same bracket. If you don't get the same bracket matching, you must have done something wrong, or that's not the way to factor. So we need this to be able to factor it out. If they don't match, then you can't factor it this way. You either have to change the order. So in grade 10, we made you change the order around, but now we're also going to have another option, which will come up for in the second half of our 2.3 lesson. We'll have a 3 by 1 option. Okay, so this one does work though, so that's good. So we're going to put the x minus 2 here. That's this guy. So put it in front or behind, up to you, and write down what's left over. So we're going to go 5x squared plus 4, and you're done. Okay, so common factor. All right. One more time. This one's a little bit new. It's like the one above. Okay. If I gave you 3 here and 4 there, how many are common between the two? 3. I have 3 here and 4 here. So this one has 3, this one has 4, right? So I can take out 3 from both of them. So you're going to take out 3 from both of them. Oops, 3. Okay, so take out 3 from here. So you're looking and going, it's not just 1 that's common, 1 and 1. I can take out 3 from each of them. So it's like they're each donating 3 to the common factor. So 3 of them. Right, so whatever the number is, if you have 3 here and 4 here, you'll have 3. Whatever the lower number is, right? Because you want them both to have the same amount taken out. So both of them have 3 taken out. I took away 3 of them. Now, write down what's left over. What's left over is this one. Yeah? Do you have any of those 3 left over? No, because you took them all 3 out and threw them in front. Okay? Minus 7. Do you have any of these guys left over? Yeah, I have 1 left over, so you're going to leave it there in the bracket. And then you decide, do I need the bracket? No, because I can expand and collect, right? So you go, wait, I could do this, and I don't need the bracket anymore. So whenever you can, I want you to get rid of any extra brackets, right? It's not necessary. I can just have like terms or not like terms. I don't need the bracket. So I do always want you to finish off. So leave this here. And this one here, x squared minus 7x plus minus 3. Can you factor this trinomial? Yeah. What'd I do?
Is it, don't you have to multiply?
21. Yep,
7?
that's it. Thank you, thank you. 21. Thank you, thank you. There you go. 7 times that? Yes, 21. Thank you. Okay. Can you factor that? It's a trinomial. Remember, you're looking for, you have a product to negative 21 and a sum of negative 7, because it's a simple factoring. There's just a 1 there. Is there anything that multiplies to 21 but adds to 7? We have 7, 3, 21, and 1. So nothing. So then there's no such thing. So you stop there. So get rid of, so I want you to get rid, rid of the extra brackets. Okay, so I do want you to get rid of the extra brackets, please, whenever possible, right here in this step. Okay, and then you look to see if it is a trinomial, if you can factor it again, or if there's a common factor. I can't factor it anymore, so you're done. We always want to fully factor, right? So factor as much as possible. The goal is to factor as much as possible. So fully factor as much as possible. So I'm going to write that down. So fully factor. There you go. Fully factor. Always fully factor means go as far as you can to break it down as far as you can. Okay. Common factor. So that's common factor with a little bit of extra, right? A little bit more than what we did in grade 10. I don't think we did such higher powers. Difference of squares. Difference of squares. Which means that you have two terms, and each one of them has to be a perfect square. So you have 64x squared and you have 81. Okay, 64x squared and an 81. So if they're both perfect squares, you can break it down to identical brackets with opposite signs in the middle. So this one is going to be 8x, that gets me 64x squared, and the 81 is minus 9 plus 9. Do I matter about the order? No, it doesn't matter. Plus 9 minus 9, as long as they're opposite signs. Okay, opposite signs, doesn't matter the order. Now, brackets. We had ones with brackets last year, okay? So I usually tell my students, if you want, you can put them in square brackets so you can distinguish which bracket is which. You don't have to. Okay, here. Is this a perfect square? 5 times 5, x minus 3, x minus 3. It's a perfect square. Is this a perfect square? Yes. Is there a minus in between? Yes. That's why we know it's a difference of squares. So I usually use a square bracket. You don't have to. You can use double round brackets. And I put here, just like what I did here. So see how I put the 8x and 8x? I'm going to separate this out. So I'm going to go 5x minus 3 and 5x minus 3. See? 25 is 5, 5, and then x minus 3, so one of each. So just like what I did here, 8x and 8x, I separated it into two groups. Then what you want is the second part. It's going to be a minus and a plus, opposite sign. So I can go minus 4 and a plus 4. Okay? Am I done?
No.
One more time. Do I need those brackets there? No. Let's get rid of them and collect like terms. Okay, so we always go, wait, there's extra brackets. I can do this, collect like terms. Okay, so always check at the end, go, yes, there you go. So in this part here, I'm checking on your collecting like terms and your algebra skills there. So that's why. So the first page of examples, I don't need too much because you're already doing so much of it here. So we go 5x minus 15 minus 4, 5x minus 15 plus 4. And this will be 5x minus 19 and 5x minus 11. Right, when you collected your like terms in the bracket. Okay, two more difference of squares. So again, recognize it, look at the first term. It's a perfect square. There's 2 m's and there's 4 n's. Okay, here, that's a perfect square. It's a 10 and a 10. So just recognize 2 terms with a minus in between, so it's a difference of squares. Again, I set up the bracket. Oh, please make sure that you have equal signs when you're working with this stuff on the first line as well. Okay, some people just don't put equal signs when you're factoring because you're so busy concentrating on the numbers, you forget to just make sure your form is good. So for all of these, so I have my 2 brackets. This first one here, I break it up. So I'm going to break it up to mn squared, right? Half of them there, mn squared. Mn squared times mn squared is m squared n4. Is that okay? Okay, so we're good there. And then all we have to do is the second part, minus 10 plus 10. Doesn't matter the order. Can I simplify that anymore? Nope. Good. All done. Then try this. Okay, see if you can set it up. Okay, can you see if you can set, if you want, use square brackets. Okay, so set it up. See if you can set it up. I'll give you a minute. I'll just turn this off.